everybody. How are you? Good. Okay, so today we are going to talk about automated machine learning. I guess you all know what is machine learning, but today we are going to talk about how we automate machine learning pipelines, what are the difficulties we face, and how to automate it. So here is the plan I will conduct for this session. So first we'll focus on the fact that automated machine learning is really gaining momentum. I think today it's one of the most trendy topics with deep learning. So I'm going to first start with this point. Then we'll focus on the precise automation process. And we will have an overview of various solutions, so like open source packages, software, and different solutions. And then we will conclude the topic. Okay, so maybe you all know what is machine learning. So machine learning is the term to say that we've got automated predictive models, okay, with parameters. So maybe one question you would ask is, how can we automate automated predictive models? Okay, so indeed, machine learning is almost an automated process. We're going to see why. So here is the data scientist. So he's playing with the data, okay, like relational databases, CSV files, data that are tracked from your smartphone or different sources. And also he's playing with the computation means. Let's say, so laptops, CPU, GPUs, and RAM. So that's the two entities the data scientist is playing with, and let's see how he interacts with these entities. So the first task he has to do is data pre-processing. So this can take a lot of time, you know. We suppose today that the data scientist spends like 80% of his time, you know, pre-processing the data, make it clean, and having like a CSV file or a relational database. So this takes a lot of time and is also very expensive. The second task he has to do is model tuning. So he has to try and validate different models, different approaches. He has to select the right parameters, you know, and this also can be very long, you know, and can take a lot of time. If we have a close look at those two main tasks that a data scientist has to do, we see that is both a repetitive task, and also it takes a lot of time, and only a data scientist can do this. And as you all know, a data scientist is expensive, so these tasks are expensive. And the idea beyond automated machine learning is to say that, okay, so why don't we replace our data scientist by a robot? By doing that, we will save like money and time. So that's the idea beyond automated machine learning. Okay, so here is the point. Once we have replaced our robot, then our robot, we can interact, you know, with the data and the computation means. But, okay, so that's a simple way to see it. But how can we have a fully automated process? That's the question. So we got the idea, okay? But how we can automate this pipeline? So here is the easy way to do it. Okay. So in terms of data, you have structured data. It's easy to automate. For example, CSV file, Excel spreadsheets, JSON files, and classical, I would say, traditional relational databases. So that's easy to automate, you know, in terms of data. And in terms of computation or algorithm, it's also easy to automate like supervised task, like classification. It could be like multi-classification problem or binary classification problem. That's easy to automate. Also, you can have regression problem. That's also easy to automate. So we will focus on this type of data and this type of task. But what about the others? The other tasks are difficult, you know, to automate. So in terms of tasks, you have, of course, unsupervised tasks that are difficult to automate, like outlier detection, anomaly detection, clustering. That's very difficult to automate, of course. And in terms of data, unstructured data, it's also difficult to deal with, even though there exists, like, of course, deep learning methods to automate, models on unstructured data, but it's, of course, trickier. So images and text. And here you can see that if we have an automated tool that can deal with the first part, with the structured data and supervised task, then a data scientist can focus more on, let's say, non-traditional algorithm like deep learning and unsupervised learning. So that's also a gain. Okay, so now we have understood the benefit of AutoML, but let's define first what is automated machine learning. Here is the common definition that people have is automated machine learning is all about automation, but it's not. It's not all about having a step that is automated. It's about having a lot of steps that are automated. We don't want our robot to focus on one precise step and deal with automated algorithm. We want our robot to be able to connect different steps automatically and with minimum human intervention. So the first criteria to define automated machine learning, so this is the most important one, and people, I guess, forget about this point, is that we want to automate the maximum number of steps in a standard machine learning pipeline. That's very important. The second one is, of course, automation. So we will require a minimum human intervention. Of course, we don't want our robot to be assisted by a human like 100% of time. So the idea is just to give inputs, to guide our robot, to give some inputs, and then the robot will automate all the steps for you. And last but not least is, of course, we want our robot to conserve the performance or human performance. That's very important. When we talk about performance, we will talk about accuracy, of course, but also about computation time. We don't want our robot, to try and test a lot of models during like 1 week, and 1 week later, the robot outputs, okay, the best model is a deep learning. We would say, oh, okay, I already know this. Okay, so now let's focus on automated machine learning today in the companies. What is the problem? So as you all know, machine learning has been, let's say, famous like 5-10 years ago. Companies have understood the benefits they can have from automated machine learning, and they have understood that, if we identify use cases, we can see the powerness of predictive models, to detect like churn prediction and so on. So they have understood the use cases. They have understood that the benefit of machine learning methods, but they struggle, they still struggle to deploy machine learning pipeline and machine learning models. Okay, so here's the diagram. You got your data, okay? So companies have also understood that they need to track data. So they store a lot of data, and then they don't know what to do then. They say, okay, I've fit a model, but I don't know what to do. Here is the negative, let's say, behavior you would find in some companies, like, I've got a lot of data, I know that there are a lot of use cases, so I need to recruit more data scientists. That's a wrong behavior you can find in some companies, because as I told you before, like 80% of the work can be automated, so it's not only about recruiting data scientists. That's the first negative point. The second one is, okay, I've understood that I have different open source packages, different models. I've fit a model, a random forest, and now it's okay. Now what can I do with this? So here we see that we've got an issue if we want to deploy machine learning models. And the last one is, no, I don't believe that automated tool can replace a human being. It's not possible. A robot cannot, replace a human, but they don't understand that a robot can, assist a human and can be as accurate, let's say, as a human, and can make you gain your time. Okay, so these are the negative points. Others don't company. They have understood what to do. So here is the solution, let's say. So first step is to identify a generic and repetitive or reusable pipeline. Like, okay, I've noticed that in 80% of cases, I need to track my data, I need to pre-process my data, I need to test different models, and then I need to predict. That's okay. That's a reusable pipeline, a generic pipeline. So that's the first step you need to do. The second one is, okay, I've identified my pipeline. Now I need to implement or buy or use an automated tool. And then last one is deployment. So once I've got my automated tool, I need to deploy my automated tool. I need to monitor my parameters. I need to watch out for a moving distribution, changing data, and so on, like A/B testing and different methods. So that's the right way to do this. Okay, so now let's focus on the automation process itself. Let's be more precise about the standard machine learning pipeline. I think you all know the standard machine learning pipeline, so I won't learn you things. But what I call step one is reading and merging several files. So you have different databases, okay? Different like relational databases. And the first step is about reading and merging my files to have one single file, with all your data. So it's like joining different databases, concatenating databases. Okay. Once you've got this, you have to bear in mind that your data could be raw data. So step two is, of course, pre-processing. Pre-processing is so the first part of pre-processing is what I call data cleaning. Data cleaning is like removing duplicates, dropping IDs, like dropping highly correlated features, dropping leaks features, and so on. Then you have data encoding. That's also very important since every machine learning algorithm takes as input numerical matrices. So you have to encode your data. So of course you will have to encode categorical features, but what if you have like missing features, dates, lists, images, text, and so on? You need to find the right way to encode your data, and that's also can be tricky and very important. Okay, so now then you move to step three. That's the let's say, optimization part. So you got one single data set that is encoded, pre-processed, and then you will try and test different models. But first, you can do what is called feature selection. So you want to select the relevant features. This could be relevant if you have like thousand of features, and there are only like 10 features that are relevant. So of course, it's important to have an algorithm that selects automatically the relevant features. And you can also have the contrary, the feature engineering. So create relevant features from the original data set. And then you can, go through model selection. So that is, try and test different models. Once you've got the right, let's say, combination, you can predict. But you can, as you can see, it's a cycle. So you can try a model, go to feature selection, try another feature selection method. Then you will need to re-optimize, retest parameters, and so on. So once you do this cycle, and like 10 times, I don't know, 20, let's say 100 times, and you got the right parameters, then you can predict. And the last step, of course, is the application steps, I would say. So you have to predict on the test set. So the test set is the set where your target is missing. And you also can have model interpretation. You can understand your model, the decision of your predictive model. That's also very important. Okay, so now let's focus on the different steps. So step one, reading and merging. So today, maybe it's the hardest step. it's not automated, or it's difficult to automate. It has always been, let's say, manual. You always read manually your data, and merging is even more hard. So it's not a priority for automated machine learning at the moment, but it's also important to consider this case that we can automate, reading and merging. So that's the first criterion. So it's red. That's why it's very important to focus also on this point. In terms of automation, you only need to have some input, like the path to your data and the target name. That's the only input you will need to give. And in terms of accuracy, so it's not the maximum level, since it's difficult to auto-merge different sources. It could take a lot of time also to different sources and to understand that, okay, this sample is already in another database and so on. So it's difficult also to automate this. Preprocessing is maybe easier, but it's important to notice that not all packages tackle preprocessing. There are a lot of packages that automate only optimization step, and you will first need to encode, preprocess manually your data. So that's the problem. In terms of inputs, it's very simple, since it's very easy to detect missing values or detect feature types like categorical feature. Dates, it's also easy to detect. So there are no inputs, so that's okay. In terms of performance, as I told you before, a lot of packages propose like naive encoding, but there are no packages that uses like state-of-the-art methods like deep learning, or they don't focus on this. So that's also important. The most important step is optimization. So when we talk about automated machine learning, people think it's all about trying, testing 100 of models, and you can find a lot of solutions that would say my tool is automated because I try 100 of models, different parameters, and that's automated machine learning. So, but that's not. That's the top priority for automated machine learning community. But I guess it's easy to automate. So that's not the point for automated machine learning. You will need some input to be accurate, of course. So you will have to give a scoring function and also a hyperparameter space if you want your computation time to be slow, to be fast. And of course, computation time can be long. So in terms of accuracy, it's difficult to get rid of this. And prediction or application is maybe the easiest step to be automated, so that no problem. Just one thing is that it's difficult to automate monitoring of models. Once you predict, it's difficult. You can have some warning about the data, but it's difficult to automate the right decision, so that's difficult. And it's fast and accurate steps, so that's okay. Now let's have an overview of various solutions in data science. So here I've put the main, let's say, automated tools. So you have open source packages, solution like Data Robot. I guess you know this tool. Or I didn't put like H2O driverless, which is very recent, but for me it's maybe the same as Data Robots. So we will only focus on Data Robots. AutoScikit-learn is an open source package built on the top of scikit-learn. So the idea is to automate, all the machine learning algorithm from scikit-learn. AutoML is also an open source package. Tpot also another one, and MLBox also an automated tool. Let's see now the criterion. So in terms of quality of automation, they are all good except AutoML. To have tested this open source package, you need to give like the feature types. You need to give a lot of parameters of inputs to your robot, so it's not very automated. If we look at the automated steps, Tpot is a very famous open source project, but it's only about using genetic algorithm to optimize different models. So it only deals with optimization, and it doesn't deal with encoding, reading, and predicting. So it's not really automated machine learning. In terms of maintenance, they are all good except AutoScikit-learn. I think that it's very. I think that the latest commit was like 2 years ago, so it's not recent, but it's a good tool. The setup is also very important. We don't want, an automated tool, but that is very, very difficult to set up, And some automated package, they say that, okay, the setup, you will do it manually, that you will need to install first this requirement, then this requirement, then, and it's too complicated for an automated tool, And open source, so they are all open source projects except DataRobot that is not free. Okay, so now let's focus on MLBox. So it's my automated package I've developed for more than 10 months on my own. It's a fully automated package coded in Python. Here you can have a look at the documentation. So it will provide you maybe all the features you will need, like encoding, data preprocessing, tuning hyperparameters, state-of-the-art model like deep learning techniques, stacking models, and also prediction with model interpretation. So you will also have a guide to install it. It's very easy, since it's on the official Python repository, so it's just pip install MLBox. It's just this. And you will have a tutorial on how to use this tool and so on. So also there is a GitHub. You can have a look at it. It's very clear. It's very easy to try it. But let's be more precise about the features that are automated. So what features are automated by MLBox? So for the first steps, I think maybe you can read. The only input is the list of different passes to your data and the target name. And of course, the MLBox will read several files, like CSV files. It will deal with JSON file or different format, and it will auto-merge all the sources. So that's very important also. If you have one data set with, let's say, 50 features and another data set with 200 features, it will automatically understand that this sample is the same as the other data set and so on. So it will auto-merge different sources, but in a clever way. So that's also very important. It will also detect the task automatically, like if it's classification or regression. That's very important. And then split between the training set and the test set. So normal feature, I would say. Preprocessing, nothing very new, except that there is one single algorithm that is new in MLBox. It's the drift. So it's all about detecting a feature that is not stable, a feature which distribution is changing between the training set and the test set. So the MLBox will automatically detect this kind of feature for you and will drop it if it's necessary. For example, you will fit a model on young people, okay? So you've got 80% accuracy. You say, oh, okay, it's good. I've got an accurate model. And when you predict, you get 70% accuracy. And you will say, but what's going on? How can this happen? It will happen if your data, the distribution has changed between the training set and the test set. And that's very important to monitor this fact, and this algorithm can do it for you. Also, it will propose you different feature encoding for the missing values, for the text, for the dates, and categorical features. So you can choose deep learning methods to encode your categorical data and so on. Optimization, you will have also feature engineering with neural networks, feature selection methods, and a wide range of models like boosting algorithm, ensemble methods, stacking methods, and so on. So you have a wide range, and you can tune all the parameter of the pipeline. So you can choose how to impute your missing data. Then you can choose a strategy to encode your categorical features. Choose a feature selection method with parameters, and then select, let's say, like 5 models, and then stack it, and you can optimize the whole pipeline. And the last one, that is prediction. So also the leak detection, that is important. So it will automatically detect like leak features and put you a warning. Okay, so just last words about the package. So as I told you before, it's a Python package, so compatible with Python 2 and Python 3. It's easy to install, like just write pip install MLBox. It will automatically download it from the official Python repository and install it for you. And then you have like a lot of tutorials on the GitHub, so that's okay. In terms of accuracy, so I've tested it on a Kaggle competition. I will show the demonstration tomorrow for the Axe session, but I've tested it on a Kaggle, and I was able to rank like top 4% using my package. So it's very accurate, and it's distributed, optimized. Also, the robot will automatically dump and read computation that you have made like several days ago. Like for instance, you have learned a random forest, and okay, you see the accuracy, and tomorrow you will need to also to refit this random forest. So it will only read from the disk, and no computation are made. And you can use also state-of-the-art algorithm like XGBoost, maybe you know this one, or LightGBM that is developed by Microsoft. Okay, so just the last points I would say is, though I will conclude about the benefit of automated machine learning. So maybe you have understood the first point, that is to increase productivity. So as I told you before, automated machine learning will allow you to automate repetitive tasks that can take a lot of time, and they can accelerate, the pipeline. So that's very important. And then a data scientist can focus, let's say, on more non-traditional issues, so like unsupervised learning and images and so on. So that's the first benefit. The last one is that a robot never makes mistakes. So if you've developed a robot and you have developed like a lot of tests, and you're pretty confident about your robot, you will avoid like human mistakes, So that's also important if you want to deploy a machine learning pipeline in industry or in a company. That's also important to avoid this kind of mistakes. And the last one that is very important is to democratize machine learning. So as you all know, today there exist a lot of open source packages like scikit-learn or Keras for deep learning. So they are all open source packages, and MLBox is built on the top of this kind of packages and is also open source. So that's very important because there are two worlds: the world that open source with the open source packages, okay, and the world with like solution like DataRobot and H2O. And we can see that it's very concurrential market, and open source project can also help to democratize machine learning. And the idea beyond that is to say that, okay, machine learning, maybe one day machine learning will be for everybody, and you can fit like a random forest without knowing one single algorithm, or without knowing what is machine learning or coding. And I would just like to finish with one quote from the Google CEO, Sundar Pichai, who said that he hoped that one day AutoML will extract the knowledge of several PhDs to make it accessible for hundreds of thousands of developers at Google. So that's the idea beyond that, is to say that, okay, so we will extract the knowledge of data scientists and make it accessible for everybody. And the idea of MLBox is the same, is to say, like in 3 or 5 years, people will be able to run automated tools like this and for free. That's all. Thank you very much for your attention. If you have Q&A. Yes. Yes. Yeah.
Beautiful presentation. Thank you.
Thank you.
I'm wondering how you did the merging.
Ah.
What kind of techniques you use for the auto?
Okay, but so the merging is very, very complicated issue. So it's a good question. Of course, you can't detect in like 100% cases if a sample belongs to another data set. So the idea beyond the ML box is to say, if I've got indexes, it's okay. I can try to look at my indexes, and if indexes A is in the other database, it's okay, I just need to merge. What if you don't have indexes? Like you read your file, and you have indexes like 0 to the shape, the number of sample. That's trickier, and here the algorithm is you compare on the common subset of features, and you try to see if there is a common, if the values are the same. If the values are the same, then you will make the assumption that this is the same sample. Of course, if you have like 2 common features, it's not very, you can make mistakes. But there will be a warning saying to you that be careful, we are trying to crunch on 2 features or 3 features. But if you have like 100 features or values in common, you would make the assumption that's the same sample.
Just quick follow-up.
Yeah?
So it looks like you're just looking at the actual data values. You don't care even what the, for example, column names might be and so on.
Column name, yeah. Yes, you look at the column name, of course. So you look at the common names, that gives you the subset of features, common features, and then you look at the values, of course. But of course, if you save your data, your database, and you delete the name of the features, that would be impossible, to look at different combination and to make it in a low time computation. That's difficult.
It can still be done. It's just
It can still be done, but you have to compute all the tuples, of features, so that would take a lot of time. So it's always, a trade-off when you try to automate things. The trade-off is, okay, I can do it, but what if I do it like in let's say 3 hours? So if step 1 takes like 3 hours to read and try to merge automatically different databases, and in one, like 2 lines of codes, you can do it like in 2 seconds. It's not necessarily automated. Maybe then, yes?
So during the pre-processing, do you drop rows and columns depending on the missing values, the amount of missing values you could have?
Yes. So
is there any specific threshold that you would use, like
yes.
10% missing, 15% missing?
Yes. So at the moment, the stable release, how it deals with missing values is that you can choose a strategy to encode missing values. Like you can take the mean, the median, the most frequent. And the next release will handle with sparse features. You can drop with a threshold, and you can also drop samples. For instance, if your training set has got a sample with 80% or 99% sparsity, you will drop it automatically. But of course, you have thresholds, but they are default configuration, But then you can adapt them.
One question. I see that data which is distributed also can be given.
Can you repeat, please?
Data which is distributed, like
yes.
HDFS, which is in distributed environment.
Yes. So
how it handles actually. Normally we go with Spark ML.
No, so it's not. It's parallelized. I used to use a distributed package. So I was able to distribute on several machines. Okay. But it was very difficult, to install. So I get rid of this package, and I use like Jobly, which is the package inside scikit-learn to parallelize computation. And so I use this one. So you can parallelize your computation. I mean, all the computation you do with the mailbox is optimized, except maybe the reading part.
Right. If data is in distributed environment, that won't be handled here.
No, it's not. It's not, actually no. That's not the that's not the philosophy of the mailbox since it's coded in Python. So it's not coded like in Spark or Scala in distributed languages. So at the moment, but it could be possible, but it's not the case at the moment.
Okay. And is there anything like once the model is trained, okay, like online training, again, if you have some new data set is there, take the existing trained model and on top of that, from there, train with a new data set. Is that feature available?
So you train your model on a training set, and then you got a new training set. That's
some subset of data.
Yeah. No. Actually, no. No, you can't read the previous model, but you can handle different databases. So if you have several training databases, you don't need to crunch it before. So you can let it like it is, first CSV file, second CSV file, even though it's training data sets, and then you have to run the ML box. So but the computation is very difficult to automate, if you have another training data set. It's not online learning, so it's difficult.
Excuse me. So, how do you take care of the correlation effect?
So I have a question here.
Yeah.
So how do you evaluate, let's say, typical ETL tools, open source tools available, such as Tailend, which have very, where you can, for example, the merging or getting data from different sources and then getting the final output. So how do you rate those tools versus the ML box?
Yeah, but
I think if I had to do it, I would perhaps say that I will use a Tailend kind of tool, which is a ETL tool. It can pull data from multiple sources. I can define my project, and then I can regularly plan it, run it as a job, and then continuously keep on getting the merged data in a rule kind of basis.
Yeah, I think there exist a lot, more and more packages, automated packages at the moment. They are not very famous, so it's difficult to know all the packages that exist. But one common feature is that they all deal with optimization parts. And that's the problem, because they all deal with optimization, step, and they not really focus on the other steps that are tricky to automate. And for me, the challenge here is to automate like reading, merging. And I'm not sure that the package you mentioned is automate like the auto merging or maybe it's not very famous or. But there exist a lot of solutions. But the idea is to compare the accuracy, of course, the time of the computation time, and also the different steps that are automated, and that's all. Also, if it's open source, because otherwise.
Hello, one question.
Yeah.
How do you compute number of hidden layers and nodes in the hidden layers? Like
Okay.
how many hidden layers do we need in the model, and how many nodes in the hidden layers?
So okay. You mean for the deep learning?
Yes.
So inside the ML box, you have one deep learning algorithm used to encode categorical features. That's only so that's the use of the deep learning in the ML box. And it's actually I've tested different configuration of deep learning structures, and there are no parameters. But of course, you can try different, parameters, different dropout, and so on. But here, it's not a parameter; it's a fixed structure. So, but first, I need to benchmark different structures and so on.
Hey, I have a question. So, how is the correlation effect between the variables taken care? Like, what is the benchmark that can be customized, or how is it taken care in ML box?
What is the benchmark of?
Correlation coefficient, correlation effect between various independent variables.
The correlation between the features,
yes.
Okay.
Yes.
That's also a threshold, so that's complicated to set as a fixed parameter.
So can that be customized in ML box? or?
You do have threshold inside, but the idea is to set the maximum threshold, to avoid the fact that if you delete an important features, that's the problem. That could be a problem. So it's just deleting, like 100% correlated features to another one, but only numerical features. That was your question? Yeah.
Yeah.
But once again, it's impossible to code, let's say, fully automated robot with no parameters. When I say MLBox is a fully automated tool, is to say that it deals with the whole pipeline. But I never say that, there is no parameters. There exist a lot of parameters, but default configuration that I tried before, like the deep learning structure. So I tried different deep learning structure, different dropout parameters, different thresholds, and then I said, okay, it's a default configuration. You can change it if you want, but otherwise it would work fine. And it's the same for the hyperparameter tuning. So I've set like a hyperparameter space, and if you want to more computation, you can do it, but it's manual.
I have a question.
Where is it?
Yeah.
Here?
In ensemble learning, do we need to check for the multicollinearity of the X variables or the independent variables, or the algorithm takes care of itself? And the different types of ensembling methods like bootstrapping, bagging, or boosting.
Mm-hmm.
So is the multicollinearity taken care by the algorithm, or we need to check for multicollinearity?
So your question is about how to automate bagging method, that's it?
Bagging.
Yeah, so there exists bagging ensembling method. Okay, so how it is built inside the MLBox is that you have the famous algorithm like random forest, okay, boosting algorithm, decision trees or linear models, and then you can decide if you want to ensemble, this algorithm. So you can choose bagging, so you can bag what the models you want. You can boost the model you want, and then you can stack the different models you want. And stacking also, this is the same. You have like default configuration. Like when you say, okay, I want stacking, it will stack like a boosting algorithm, a bagging algorithm, and a linear model. That's what it will do, but you can change and put like 100 models for the first layer, and you can also add 10 layers.
No, my question was, multicollinearity is taken care or not?
Actually, the models can handle this. You have parameters to deal with multicollinearity. Otherwise, it's a preprocessing step. So it's the second step, and you will get rid of highly correlated features before fitting a model. Okay.
Okay, last question from me. Thank you for your presentation.
Hello.
Really insightful. Just wanted to check, when we talk about different data sets, is it possible to link it to open data sets? For example, let's say that I want to look at my transactional data with, let's say, macroeconomic indicators of currency. So is it possible?
Yeah, I've think about it, but it's difficult to automate. So yeah, the idea is just you have your training data set and you want to add like weather data, or I don't know. That's not possible at the moment. Or otherwise, it would be possible if you also have the target features. Maybe it could be possible, but if you only have like other data sets, it's impossible, to merge automatically, and so it's difficult.
Hello.
Otherwise, you can do it before. That's always the way I do when I can't automate, this kind of stuff. I do this kind of step before. So I crunch my data before with external data, and then I run MLBox. And that's the same if I want to do manual feature engineering. I do it before, and then I run MLBox.
Hello. One question, last question.
I apologize, but the time is over for question and answer now. So thank you, Mr. Romblay.
Thank you very much.